Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I will be going over how to calculate pH either from your H plus concentration or your OH minus concentration. So again, it's the same as before with regard to finding your OH or your H plus concentration. This time you're going to want to take the negative log of your H plus concentration once you find it. So again, you're going to want to use the equation that the OH minus concentration multiplied by the hydronium ion concentration is equal to 1.00 times 10 to the negative 14 molar squared. So you're going to be either given an H plus concentration or hydronium ion concentration or hydroxide ion concentration. And then you're going to, whichever one you're given, you're going to have to solve for H plus or the hydronium ion concentration. Once you've got the hydronium ion concentration, it's just a matter of taking the negative log of that concentration. So first they give us the in A, they're giving us the hydronium ion concentration, H plus. That's what pH is referring to as the concentration of H plus or hydronium ion concentration. So here they're giving us that hydronium ion concentration, so all we need to do is take the negative log of that concentration to get the pH. So if we take the negative log, right, so we use our calculator, take the negative log, and you're going to get, so I'm going to take the negative log of this 1.8 times 10 to the negative 4 molar, and that's going to be equal to the pH, which is gives us 3.74. So that would be 3.74 is the pH. Okay, now one thing I want to point out about significant figures is whenever you're going from scientific notation or when you're going from the concentration and you take the log of or negative log of your concentration or whatever number you're taking the log of, anytime you take a log, the way you determine the number of digits that you should have in your pH or whatever your answer is after you take the log of something is determined by the number of significant figures in the answer or in whatever you are taking the log of or negative log of. In this case, here we have two sig figs. Those two sig figs are going to translate into decimal places for the log. Okay, so since I have two decimal places, since I have two sig figs here, that means that translates into two decimal places in the answer that I get. If I had three sig figs, that would translate into three decimal places in the answer I would get for the log. And that's how it works. Okay, so here I have two sig figs, and that translates into two decimal places. So I have three sig figs here, but I'm interested in the decimal places. So two sig figs here translates into decimal places here. Okay, so what's next? So here I'm given the OH minus concentration, so I have to do an extra step first. So the first step I'm going to do is I need to use this equation here to solve for the H plus or the H plus concentration or hydronium ion concentration. So the first thing I want to do is plug in 1.3 times 10 to the negative 2 molar I'll have my hydronium ion concentration is equal to 1.00 times 10 to the negative 14 molar squared. I solve for that, get my calculator, and I get 7.7 times 10 to the negative 13. So the H3O plus concentration is equal to 7.7 times 10 to the negative 13 molar. Let me double check to make sure I got that right. Yep. And now all I need to do is take the negative log of this. So negative log of 7.7 times 10 to the negative 13 is equal to the pH, right? And what is that equal to if I do my calculation? So it's going to be 12.11 pH, 12.11. And looking at both of these, this pH, this indicates acidic solution. So we have an acid, acidic, and this indicates that we have a basic solution. So the pH is higher than 7, basic. pH lower than 7, acidic. Okay, and that's how you would do these sorts of problems. So we have two more, so let's go ahead and do the same thing with these guys here. Okay, so, oh, and I want to point out again, I have 2 sig figs in my answer here that I took the negative log of. So my answer should have 2 decimal places for the log. Okay, here again they give me H plus concentration. They give me the hydronium ion concentration, so I don't need to do any extra step. I just take the negative log. So I'm going to take the negative log of 9.5 times 10 to the negative 9 molar. And that's going to be equal to, again, the pH, which is going to be equal to, okay, 8.02. So this would be 8.02. So this is going to be basic, pH higher than 7. Okay, and finally we have OH concentration, OH minus concentration, hydroxide ion concentration of 7.1 times 10 to the negative 3. Again, you can see that this is higher than we would have for a neutral solution. So this would indicate basic solution here. But let's go through the steps. So we want to find the H plus concentration. So we're going to have to use our equation here again. So here we have 7.1 times 10 to the negative 3 times our H3O plus concentration is equal to 1.00 times 10 to the negative 14 molar squared. We divide both sides and we get an H3O plus concentration of, and that's going to give us 1.4 times negative 12. So this is going to be 1.4 times 10 to the negative 12 molar concentration, and then we take the negative log of that, which is going to be 1.4 times 10 to the negative 12 is equal to pH, which is then equal to, if we take our calculation here, okay, So we get a pH of 11.85. So again, that's going to be basic. So I hope this was helpful. This is showing you how you can use this equation to find either the OH concentration or the hydronium ion concentration, and then you use your negative log to find the pH. So I hope this is, again, I hope this was helpful. If you like these videos, please like, share, subscribe, hit the notification bell. Thanks for joining me, and I'll see you next time.